Thanks for tuning back into the channel. Make sure to like and subscribe for more software engineering content. Let's get right into an introduction of software processes. So what is a software process? Software processes are structured sequences of activities, tasks, and practices necessary to develop and maintain software systems efficiently and systematically. These processes outline the steps such as requirement analysis, design, coding, testing, and deployment to ensure that the software meets user needs and quality standards. By providing a well-defined framework, software processes help manage complexity, mitigate risks, and enable collaboration among development teams, ultimately leading to more predictable and maintainable software products. So the main pieces of software processes include specification, design and implementation, validation, and evolution. Specification is the phase where the requirements of the software are defined, detailing what the system should do, and it serves as the foundation for all subsequent development activities. Design and implementation involves creating the software architecture and writing the actual code, translating the requirements into a structured solution that fulfills the specified needs. Validation is the process of verifying that the software meets these requirement needs and works as intended, typically through testing and quality assurance measures. Evolution refers to the ongoing process of adapting and improving the software to meet new requirements or correct issues, ensuring that its relevance and functionality over time. So software process models are abstract representations that outline the various stages and activities involved in developing a software system. These models provide a structured framework for organizing and guiding the sequence of tasks, such as requirement gathering, design, coding, and testing, in a cohesive and manageable way. By using these models, we can visualize, standardize, and improve the software development process, making it more predictable and adaptable to more different project needs and these different constraints. So now we're going to move into an overview of the process models themselves. So our first two are plan-driven or your predictive model, and then your agile or adaptive model. So plan-driven processes are highly structured with detailed plans, schedules, and requirements all defined upfront. These processes rely on a linear or sequential progression of stages, making them suitable for projects with stable requirements where predictability and thorough documentation are essential. Plan-driven methods prioritize control, documentation, and comprehensive testing before any deployment, aiming for a complete and fully tested solution before the delivery. Now, agile are flexible and iterative processes focusing on delivering small incremental improvements to the software with each cycle. Agile methods are well suitable to projects involving evolving requirements or where rapid adaptation is necessary, as they prioritize collaboration, customer feedback, and quick responses to change. Agile emphasizes working software over documentation, customer collaboration over contract negotiation, and flexibility over rigid planning, enabling teams to refine and evolve product continuously throughout the development. Many process models will use a unique blend of both of these models to adapt to changing project needs and requirements. So first off, the waterfall model. It's a traditional sequential model that takes a linear approach to development. In this model, each stage will be completed before moving on to the next. The steps of the waterfall method include gathering requirements, designing, implementation, testing, and maintenance. In the initial requirement step, detailed requirements are gathered, documented, and agreed upon. This serves as like the foundation for the entire project, specifying what the system must achieve. Next, in the design step, it'll use the requirements as a blueprint, creating a detailed system architecture. This includes both high-level, defining the system architecture, and low-level design, specifying components and their interaction. Implementation is where developers will use this actual code, translating the design into a working software product. Each component is built and integrated according to design specifications. After implementation, rigorous testing is conducted to identify and resolve defects, ensuring the software functions correctly and meets the original requirements. Once deployed, the software enters maintenance in the maintenance phase, where issues are corrected and updates are made when necessary. The problem within the waterfall model comes in its flexibility to accommodate change. Because it's sequential, once it's started, it has a hard time adapting to change. Next up, we have incremental development. which is an agile approach. It takes a much different approach than the waterfall method. It's developed and delivered in small, manageable increments rather than as a complete product in a single phase. Here, the specification, development, and validation activities are interwoven throughout the process, meaning requirements can evolve and components are gradually designed, coded, and tested in cycles. Each increment delivers a small portion of the functionality building towards the final system. In incremental development, requirements are improved during the development process, allowing for more economical and effective modifications without requiring a whole project redesign. The project becomes more flexible as each increment permits modifications based on the present requirements. The customer receives functional software with each iteration, enabling frequent input and early understanding of how the solution will satisfy their needs. By addressing problems or improving functionality early on, this feedback loop helps engineers raise the product's value and lower the possibility that it will fail to meet the customer expectations. Next up, we have integration and configuration. It involves assembling systems using pre-existing commercially available components or modules, often referred to as commercial off-the-shelf products or COTS. Instead of developing software from scratch, developers will select, configure, and integrate existing software components that meet project requirements either as standalone products or as part of a larger framework. Some of the advantages include the ability to use pre-built components to significantly shorten development time, allowing for faster delivery since developers can bypass the time-consuming process of creating each feature from scratch. This is particularly beneficial for projects with very tight deadlines. It allows the developers to leverage established components, reduce costs, as there's no need to fund all the development and testing for each module. And the reuse of well-tested components can also lower the costs associated with debugging and quality assurance. Next, we have one of the most important aspects of software development today, and that's coping with change. So change in software projects is just inevitable due to several factors, including business needs, evolving business needs, the introduction of new technology, and the constant shift in platforms and environments. So some of the main strategies for adapting to these changes includes change anticipation and change tolerance. So change anticipation is a proactive method in software development that anticipates and accommodates future changes before they occur. Prototyping is one of the most effective methods of anticipating change since it involves generating early reduced versions of the software to test the requirements, design components, and user demands. It enables developers to anticipate prospective changes in the system, business requirements, or technology, allowing them to include flexibility and make more informed judgments regarding the project's direction. Change tolerance is vital for managing the inevitable evolution of business needs, technologies, and platforms. Incremental development is a proven approach for achieving this tolerance as it divides the project into a smaller, more manageable part that can evolve over time. By adopting incremental development, teams can accommodate changes with minimal cost, reduce risk, and integrate new technologies and deliver continuous value to stakeholders. Now we'll talk about software prototyping, which we mentioned in the last slide. It's essential in software development, especially during early stages of a project. It entails developing an early, generally reduced version of a system known as a prototype, which is used to gather input and modify system requirements. The primary goal of prototyping is to define requirements, show functionality, and detect potential concerns early in the development cycle. Lastly, we move into a very important section of software development from the management viewpoint especially, and that is how to improve and measure your project. The process improvement is the methodical attempt to improve and streamline software development procedures to raise software quality, save costs, and shorten development times. Organizations can detect inefficiencies, implement best practices, and optimize processes through the process improvement, which results in software solutions that are more dependable and maintainable. There's two main types of process improvement. First off is process maturity, which emphasizes standardization, project management, and adherence to industry best practices. Frameworks such as the capability maturity model provide structured guidance for organizations to gradually mature their processes. So this strategy provides a robust foundation, allowing businesses to obtain consistent and dependable results across projects. It decreases unpredictability in project outcomes and boosts stakeholder confidence by emphasizing accurate documentation, planning, and rigorous quality assurance. While this approach can produce high quality results, it often comes with significant overhead in terms of documentation and process adherence, which can slow down development and reduce flexibility. The Agile approach to process improvement focuses on iterative development, adaptability, and decreased overhead. Rather than rigorously adhering to predefined phases, Agile encourages continuous delivery of smaller pieces of working software, allowing teams to adapt to changing requirements. So in Agile, projects are broken down into these small manageable increments called iterations or sprints. Each iteration typically lasts 1 to 4 weeks and involves a complete cycle of planning, development, testing, and review. Instead of waiting until the end of the project to release a full product, Agile teams deliver a functional part of the system in each iteration. This allows for continuous feedback from stakeholders and end users, which helps align development with customer needs and adapt to changes more efficiently. Agile focuses on minimizing non-essential processes, documentation, and formalities, aiming to keep the development process lightweight. Unlike traditional plan-driven methods that require detailed upfront planning and extensive documentation, Agile streamlines these aspects, allowing teams to devote more time to the actual development of the software. So measuring your process improvement is essential for validating the effectiveness of changes, optimizing resources, improving time efficiency, and making more informed decisions. It ensures that teams are on the right track and provides the foundation for continuous improvement, ultimately helping the organization deliver higher quality software faster and more efficiently. So defect rates are one of the most common metrics used in software development to measure the number of defects or bugs identified in a software product over a given amount of time. This metric helps teams assess the quality of their software and development processes. Effort in person days is also a very important aspect, and it represents the overall amount of time and effort used to execute a certain software development assignment, project, or phase. It indicates the time spent by all team members working on a project, which is commonly measured in days and is frequently reported to better understand resource usage and project costs. The measure is essential in project management since it helps estimate the entire cost of a project and may be compared to the expected or planned to determine whether a project is on track or requires additional resources. And last, we move into the capability maturity model, which I mentioned on a previous slide. It's a framework for assessing and improving software development processes. Developed by the Software Engineering Institute, the CMM will define 5 levels of maturity for an organization's software development processes. So level 1, we have initial. Processes are unpredictable and reactive. Success depends on individual effort, not standardized practices. Level 2, you have managed. This is where basic project management practices are in place to track costs, schedule, and functionality. There's a focus on project management and ensuring that the processes are planned and executed. Level 3, we have defined. This is where processes are documented, standardized, and integrated across the organization. There's a focus on improving development practices. Level 4 is quantitatively managed. The organization will use data and metrics to understand and control process performance. There's an emphasis on statistical control and continuous improvement. And your last and best step is continuous process improvement is a focus. This optimizes the entire process and makes sure you're in the best place possible. Thanks for watching. I hope you guys enjoyed the video. Keep your guys' eyes out for the next one.